Khurais's Crude Increment Program is the largest oil increment development to be undertaken not only in the history of Saudi Aramco, but in the oil industry to date. This is part of Saudi Aramco's established plan to increase crude supply due to the increasing energy consumption in the world. Khurais's Crude Increment Program will provide 1.2 million barrels per calendar day of stabilized Arabian light crude blend from Khurais, Abu Jafan, and Mazalish fields, which is sent directly to customers through the East-West pipeline. In addition, to maintain pressure in reservoirs while crude oil is being withdrawn, the program will increase Khurais plant seawater production capacity by 4.5 million barrels per calendar day. Khurais field was discovered in 1957, began production in 1963, while Abu Jafan and Mazalish fields were discovered in 1972 and were brought on stream in 1982. Khurais field is the biggest of the three fields with an area of 2,890 square kilometers. It is located approximately 250 kilometers southwest of Dhahran. Abu Jafan field has an area of 520 square kilometers and is located southwest of the Khurais field. Mazalish field has an area of 1,630 square kilometers and is located southeast of the Abu Jafan field. "236 oil production wells will be drilled to meet the production of 1.2 million barrels of oil per calendar day, connected by 8 and 10-inch flow lines above and below ground." The scope of Khurais central processing facilities consists of 4 GOSP, 2 gas trains, 3 oil storage tanks, 2 NGL spheroid tanks, 5 CGT-driven seawater injection pumps, plant utility, control room, workshops. Flow lines will be connected to 14 trunk lines to deliver the wet crude oil from the fields to the Khurais central processing facilities that will be received by each of 4 by 25% manifold headers. Each production manifold has the ability to route the design capacity of the wet crude to one of the 4 gas oil separation plants. 4 parallel gas oil separation trains, each with a capacity of 300,000 barrels per day, will produce a total of 1.2 million barrels per calendar day of stabilized crude. The stabilized crude will be pumped to the product pipeline or storage. In each train, crude will be fed into a high-pressure production trap where the oil, water, and gas fractions are separated. The separated oil will then flow to the low-pressure production trap, which will operate at atmospheric pressure and be further degassed. The degassed crude oil from the low-pressure production trap will be sent to the wet-dry crude heat exchanger and heated, using the heat from the hot stabilized product crude. Then, the degassed crude will be sent to the dehydration train, consisting of an electrostatic dehydrator desalter to remove the water and salt. Desalted crude oil will then be sent to the crude stabilizer to remove hydrogen sulfide and other light hydrocarbons. Stabilized crude will be sent directly to the common suction header of 4 by 50% crude shipper pumps via 48-inch by 3.5 kilometer pipeline, then to the East-West crude pipeline. When the East-West crude pipeline batches Arabian superlight crude, oil storage facilities will be available to provide the flexibility of routing a whole day's production through 3 by 50% oil storage tanks. The gas from the low-pressure production trap and the crude stabilizer column will be compressed in the low-pressure compressor before being mixed with gas in the high-pressure production trap and entering the first stage of the high-pressure compressor. The discharge from the high-pressure compressor's first stage will enter the second stage of the high-pressure compressor before being routed to the gas processing facilities. The gas processing facilities will comprise 2 by 75% gas trains that will provide gas dehydration and dew point control for the gas from the 4 gas oil separation plant trains. The gas from the gas oil separation plant trains will be cooled and dehydrated to a water dew point of 45 degrees Fahrenheit in the TEG contactor. The product streams will be 315 million standard cubic feet per day of sour gas, which will be exported via 38-inch by 142-kilometer sour gas pipeline to the Shedgum gas plant. Hydrocarbon liquids will be collected in the condensate feed separators and fed to the NGL stabilizer. Methane, hydrogen sulfide, and most of the ethane will be removed. The stabilized 70 million barrels per calendar day of NGL will be routed via 16-inch by 3.5 kilometer pipeline to Shedgum Yanbu NGL pipeline. The Khurais Central Processing Facilities will have low pressure, high pressure, and common flare systems to release gas during any relief scenarios. Additionally, 2 cryogenic burn pits are provided to handle flaring of any hydrocarbon liquids. The water from the water-oil separator will be disposed of through a segregated injection header to the Khurais field. This water is not sufficient to maintain pressure in the reservoir while the crude is being withdrawn from the field. A major expansion at Khurais Seawater Treatment Plant, undertaking to increase seawater injection capacity by 4.275 million barrels per calendar day, of which 2.375 million barrels per calendar day will be injected into Khurais fields, and 1.9 million barrels per calendar day will be injected into 135 injection wells in Guar Field. The Seawater Expansion Project will provide seawater supply and injection facilities to maintain pressure in reservoirs while crude oil is being produced. Water injection is one of several measures taken to maximize reservoir recovery and therefore supports the corporate objective of managing and protecting the kingdom's resources. This project will support the treatment, supply, distribution, and injection of seawater during Phase 1 of the proposed Khurais area development and Gawar field production enhancement. Urea seawater treatment plant expansion will include new equipment in the intake system, 9 treatment modules with a capacity of 500,000 barrels per day, and 4 shipping pumps with their control stations. A total of 4.5 million barrels per day will be transported to Khurais and Gawar fields through new pipelines, Quad 2 and QUU4, while the electrical and process control system of the existing plant will be upgraded. Plant utilities including the poly, coagulant, hypochlorite generation units, plant air, raw water, potable water, nitrogen gas, and sulfur plants will be upgraded and/or extended to support the new facilities. Moreover, the new administration building will be constructed adjacent to the Arabian Gulf. This building will be parallel to many other expansions inside the plant. Seawater will be drawn into the intake structure from the seawater intake channel through 65 pipes, each with a diameter of 48 inches, dosed with hypochlorite, and pass through 2 existing plus 1 new set of bar and drum screens. The bar and drum screens remove trash and debris as small as 0.2 centimeters in diameter. Water will pass through vertical lift pumps that have a capacity of 2.4 million barrels per day each, and then water is lifted through 54-inch discharge lines to the above-grade canal. The above-grade canal that acts as a reservoir will be extended during this project to its full design length. Excess seawater in the above-grade canal will overflow to the intake through overflow flume pipes. Each of the 9 new treatment modules will have feed pumps that draw seawater from the above-grade canal and send it to 4 high-flow sand filters. Polyelectrolyte and coagulant are injected prior to the filters to enhance the filtration process, while the hypochlorite is injected to kill the marine growth in the system. Treated water that has tight specifications, for example, total suspended solids of less than 0.2, is then sent to the deaerators, where the dissolved oxygen is removed by injection of both nitrogen gas and sulfurous acid. Water with less than 10 parts per billion of the dissolved oxygen is sent to the discharge headers through the column bottom pumps. Biocide chemicals are injected at this stage to control the bacterial growth in the system. After that, water passes through the shipping pumps and the control stations to the water transmission pipelines. The Uthmaniyah Water Supply Station is the cornerstone of all the southern area water injection facilities. A major part of this plant upgrade is to install a new combustion gas turbine with pump to boost the water pressure and deliver it to the Hawaya water injection plant. Moreover, the upgrade will include a new DCS system, air instrument system, new control room, 480-volt substation and fuel gas pipeline. 2.36 million barrels per day of treated seawater is transported from the Khurais Seawater Treatment Plant to the Uthmanaya Water Supply Station via the 60-inch QUU-4 pipeline. The Uthmanaya Water Supply Station will deliver 4.51 million barrels per day to the Hawaya Water Injection Plant. Hawaya Water Injection Plant services two areas, namely Hawaya and Harad. While it injects water in the Hawaya area, it boosts the pressure in the Harad area. To inject 2.52 million barrels per day in the Hawaya field, this project will install an additional pump train with a capacity of 12,000 gallons per minute, upgrading the DCS system, install a new air system, and upgrade various existing booster pump components. The Hawaya Water Injection Plant will also pressurize 1.99 million barrels per day from 260 to 680 psig in order to transport the treated water to the Harad plant. The Harad water injection facilities within the Harad GASP will handle the pressurized 1.99 million barrels coming from the Hawaya Water Injection Plant, then injected into the field using two new seawater injection pump trains with a capacity of 12,000 gallons per minute each. The final destination of treated seawater is to be injected in the ground with a pressure of 2,500 psig. The Andar Water Injection Plant will undergo a major upgrade to support the new increment of water injection, such as a new control room, electrical substation, maintenance facility, new security gatehouse, fuel gas pipeline, instrument air compressor, and a new evaporation pond. The new plant configuration on the north side will support Gawar field production by installing a 19,500 gallon per minute combustion gas turbine-driven pump train. Water injection plant will house a 13.8 kV substation, process interface building, instrument air system, fire water system, and team building and water injection facilities. To achieve 2,850 psig for the 2.14 million barrels per day of treated seawater coming from the Andar Water Injection Plant, the Khurais Water Injection Plant will utilize 5 turbine-driven injection pumps, each delivering a total of 12,500 gallons per minute to both Khurais and Abu Jufan fields. The Abu Jufan substation is located 70 kilometers southwest of the Khurais Water Injection Plant. This substation will provide the power for the oil well's electrical submersible pumps, cathodic protection, and other uses in the Abu Jufan area. The final destination of treated seawater is to be injected in the ground with a pressure of 2,500 psig, 2.14 million barrels per day will be injected in this field at this phase of development. The construction of the Khurais residential and industrial complex will support the development of the fields and will consist of the following facilities for 1,200 people. 7 Saudi Aramco residential buildings, a community center, outdoor and indoor recreation facilities, a masala, an administration building, a residential workshop and warehouse, an airstrip facility, as well as infrastructure roads to the highways connecting the facilities. Khurais Crude Increment Program will provide 1.2 million barrels per calendar day of stabilized Arabian light crude blend from Khurais, Abu Jufan, and Mazalish fields. Saudi Aramco's team vision is to bring a world-class facility into production, meeting applicable environmental standards, and to be recognized as best in class for quality, design, safety, and reliability.